I have a few more questions on the Jamboard, so I'll just do a video of working through those solutions. This first one is 8a on page 45. We've got a cubed root in there, and remember that cubed root doesn't work with that multiplying by the conjugate. That's not something that works for cubed roots. So whenever I have a different kind of root, like not just a square root, I want to do a substitution. I'm going to say let u equal the cubed root of x. Okay, remember that you are going to need to take the opposite of that and figure out what would x equal. So if u is the cubed root of x, then x is u cubed. You would just cube both sides. We also have to convert the limit and talk about as x is approaching 8, u is approaching the cubed root of 8, which is 2. So I'm going to change the limit operand in the question. So now I'm just going to make all of those substitutions and rewrite this as the limit as u approaches 2. Now u is the cubed root of x, so u minus 2 over u cubed minus 8. And then the limit as u approaches 2, that's a difference of cubes on the bottom, so I have u minus 2 times u squared plus 2u plus 4. That will reduce. Don't forget that you still got a 1 on the top there. So this is the limit as u approaches 2 of 1 over u squared plus 2u plus 4. Now I can sub that in and drop the limit notation. So it's 2 squared plus 2 times 2 plus 4, which is 1 over 12. The next one is from page 74, and this is looking at the derivative from first principles. So here we want to say f prime at x is the limit, and this one's going to be pretty big and messy, as h approaches 0 of f at x plus h minus f at x over h. So this is the limit as h approaches 0 of, here we've got 6 times x plus h cubed minus 7 times x plus h minus 6x cubed minus 7x all over h. Now I hope you guys will be okay just kind of for the sake of space. I'm going to expand and collect like terms, that x plus h cubed. If you, you would just have to write out x plus h times x plus h times x plus h and like FOIL it a whole bunch and then collect like terms. I'm going to kind of cut right to the answer here. So h approaches 0. I'm going to have the 6 out front though. So 6, and this is x cubed plus 3x squared h plus 3xh squared plus h cubed. And then I've got minus 7x minus 7h minus 6x cubed plus 7x. So multiplying careful in that negative into the second bracket. And then this is all over h. So expanding out this bracket, I've got 6x cubed plus 18x cubed h plus 18x h. Oh, that was x squared. Sorry, x squared h on that one. Plus 6h cubed minus 7x minus 7h minus 6x cubed plus 7x. Whew, that's a mouthful. Over h. So now I'm going to reduce a bunch of stuff out. I've got 6x cubed and minus 6x cubed. And then I have minus 7x and plus 7x. And anything else? I don't think I have anything else there. So I am going to common factor the stuff that's on the top that's left. They all have an h. So then I would get 18x squared plus 18xh plus 6h squared minus 7 all over h. And then we can reduce those h's, and we have the limit as h approaches 0 of 18x squared plus 18xh plus 6h squared minus 7. And then I'm at the point where I can take the limit, so I'm going to drop that limit notation and just sub in a 0. So I get 18x squared plus 18x times 0 plus 6 times 0 squared minus 7. So the middle two terms 0 out, and I get 18x squared minus 7. So that's the derivative of that from first principles. Pretty big and pretty messy. Whenever you get bigger than a quadratic, it ends up being a lot of terms to multiply out. The last one here is sort of similar. We want to find an equation of a line tangent to this graph. So first of all, we have to find the derivative from first principles. So to get the slope of the tangent, we'd have f prime at x equals the limit as h approaches 0 of f at x plus h minus f at x over h, which is the limit as h approaches 0 of, this is going to be the square root of x plus h plus 1 minus the square root of x plus 1 all over h. To get this to simplify, we're going to need to rationalize the denominator, or rationalize the numerator, I guess, multiply by that conjugate. So I'm going to multiply by x plus h plus 1 plus root x plus 1, and I'm going to do that on the top and bottom. So the limit as h approaches 0, I'm not going to multiply in on the bottom at all. That is just fine, I think, there. Now, on the numerator, I'm going to multiply this times this, and that will be the same thing, the square root times itself. So I just get x plus h plus 1. And then this multiplying by the conjugate works because it cancels out those middle terms. So I get plus those two square roots minus the two square roots. So those would cancel out, and then I get minus that square root squared, so it's just minus x plus 1. So the limit as h approaches 0. Here, I hope everybody's okay if I skip this part here. We've got x and then a minus x. And here we've got a 1 and then minus 1. So we just end up with an h on the top. So root x plus h plus 1 plus root x plus 1. Need a bigger fraction sign there. Now I can reduce the h's top and bottom. That's always our goal, right? We want to get rid of that indeterminate limit. So we've got the limit as h approaches 0 of 1 over root x plus h plus 1 plus root x plus 1. And now I can drop the limit notation. That's the square root of x plus 1 plus the square root of x plus 1 when h is 0. So it's 1 over 2 times the square root of x plus 1. Now we want to talk about where this derivative would be parallel to the graph of this. The tangent is parallel to the line. So this line that we're given, I want that to be in y equals mx plus b form. So 6y equals x plus 4, and then divide out a 6. So y equals 1/6x plus 2/3. So m value here is 1/6. So we want to figure out where is the tangent. Make myself some more room here. Where is the tangent to that original function, f prime at x, parallel to the line? So f prime at x equals 1/6. So I'm going to set 1/6 equal to 1 over 2 root x plus 1. And then I'm going to cross multiply. So 2 root x plus 1 equals 6. Divide out the 2 and we get square root of x plus 1 equals 3. We can square both sides in here. And then we get x plus 1 equals 9. So x equals 8. So that's my x value. To figure out the y value, that would be f at 8. So that's the square root of 8 plus 1, which is root 9, or 3. So my point is 8, 3, and my slope is 1/6. So I'm very, very tight for space here, but hopefully we're all okay if I squeeze this in. So I get 3 equals 1 over 6 times 8 plus b. 8 over 6 is 4 over 3, so that's 9 over 3 minus 4 over 3 equals b. b is 5/3, and then squeeze this in at the end. Y equals 1/6x plus 5/3. So that is the equation of the tangent through this point 8, 3 that is parallel to the given line.